Okay, let me review a little bit what we learned on Monday. So every time we learn about the explainability. Explainability. So it means we want to explain what is the result. We want to know the description about the result. So if you look at this table, okay. So I'm using the advertising data set. And I'm using regression. Do you remember what is regression? Regression is one of the machine learning when the target is numerical. So when the target is numerical, it means you will get the performance method such as MSE, RMSE, MAE, MAPE, and R square. So if you look at this one, this is the error. What is error? It is the difference between the actual and the prediction. Yang cakap pada sistem cakap. Then, if the error is minimal, that's the test. So we look at the MSE. Okay, this is the lowest. Let's look at the RMSE. Okay, this is the lowest. So how can we determine the lowest? We can see from the other model. So we use the cross validation, and the false is 5. Do you remember? The cross validation. You can take a look on your PowerPoint. What is the cross validation and 5? So using the cross validation and 5 times, using the linear regression, this is the result. Using the decision tree, this is the result. There is another algorithm called SVM. This is the result. The KNN, this is the result. And the random forest, this is the result. So using this cross validation, we got those 5 models, and let's see. RMSE is the lowest. RMSE is the lowest. MAE, this is also the lowest. MAPE, this is the lowest. And R square. What is R square? It is to show the relationship between those attributes. For the R square, we want to see the maximum score. So this error, we want to get the minimum. But for the R square, we want to get the maximum. The highest value will be the better. So here is the highest score. Then we will say that random forest is the best model for this data set. Now, the question is how to explain random forest. If you use the distribution tree, we can show the tree. However, if you use different model, there will be a different way to explain model. So some model is too complex and it is not easy to explain. For example, if you use the SVM, okay, so I'm not explaining about the algorithm at all. But if you use SVM, it is different with the method of decision tree, and how to explain the SVM is also different with how to explain decision tree. In the classification, let's see this example. So
So
I'm
I'm
using
using the
the iris
iris
data.
data.
I
I
think
think
you
you
still
still
remember
remember
the
the
iris
iris
data.
data.
We have
We
the
have the
septal length,
septal width,
septal length,
pedal width, and then
we can determine three flowers. So there are three flowers. Now we want to check whether the model can distinguish the flowers, and we call classification because the target is categorical. When the target is categorical, then we will do measurement such as so we learn about the CA. This is the classification accuracy. We learn about the F1 score, precision, recall. So those four things we want to get the maximum. When it is the highest value, then it's the best. So I have not explained yet about the AUC and MCC. Basically, they are also similar. So we want to get the highest score. We will get the highest score. But let's see this one. If you look at those models, we have the decision tree. You learn about the K and M. You know about the logistic regression. Now I'm adding three different models. This is SVM, random forest, and naive bias. So those three models are the additional model, and we want to perform using the cross relation with K equals to 5 and this is the result. Now let's see. If you look at the CA, the accuracy, K and N is the best. What about the F1? F1 score, this is not the best. What about the precision? This is also the highest. What about the recall? This is also the highest. Okay. But what about the AUC? SVM is the highest. So how can we choose this one? So we can say that. Okay, let's choose again because among those methods, show the best on four measurements. So on four measurements, KNN is the best. Only one measurement, AUC for SVM is the best. Okay. But sometimes there might be some red. For example, in the KNN, maybe this is very simple. So we can explain it very well. SVM consider something more, something which is complex. So sometimes maybe we need to consider also the SVM because the difference is not that huge. Okay. So the difference here 0.960 and 0.967. So the difference is not that different. Then sometimes we can say, okay, SVM might be also a good alternative. What more? But now let's see that we need to see the best one. So in this case, the best is KNN. Because among four, they are the best. Maybe including this one, this is also the highest. So five among six measurements, they are showing the highest value. So this is the way to do the classification. Now, uh, on Monday, I explained to you when you do in the orange, you can have additional module. Okay. The additional module means you can go to the option and then you can add some of the additional modules. You can do the add-on and then you can see a pop-up and you can install what you want to use in your orange. Okay. So in this case, so you can go to the options add-ons and there are many kinds of modules. So today I'm going to explain the module explain. So explain, you can see the explanation here. So explain, it provides extension for explanatory AI. So we want to explain more. So explain, it is for the classification and regression of model. Explain which features contribute the most and how they contribute toward prediction for a specific class. And explain which feature contribute the most to the prediction for a single instance is on the model and how they contribute. So the other module I will explain it after the mid exam. Now let's see. I hope that you already installed the explain. Now I want to see how the explainable features work in orange. When you have the file, okay. So let's say this is the iris data. You can see the sample line, sample width, petal width, and the iris sample. Now I'm using the decision tree, and you can see the preview. Okay, so this is the basic classification. And we can see this is the decision tree. So the most important attribute is petal. And among this one, the iris contains 50 among 150 data. There are 33.3%. It is the iris. No, my question is, this data is binary classification or multi-class classification. This is binary classification or multi-class classification. Multi-class. More than two. Good. Thank you. So we have iris setosa. We have iris virginica. And we have iris persicon. So the class there are three. Because it is more than because this is multi-class classification. If the class is two, let's say play golf. Okay. So we have yes and no. Then it is binary classification. Okay. You can see if it is multi-class classification, the value will be very low. in this case.
Okay.
So sometimes it
Sometimes
can
it
be
can
like
be like
60%,
60%,
or
or
sometimes
sometimes
it
it
can
can
be
be
like
like
10%.
10% maybe.
Because in multi-class
Class
classification,
classification,
the number of
classes
classes are more
more
than
than
now.
now.
You know
You know
that
that
when we
when
have
we
this
have this
one,
one,
we
we
can
can
check
check
the
the
score. So this
This
is
is
the easy way.
easy way.
Check the
Check the
score.
score.
Okay, we
Okay,
have
we have
the
the
score
score
for
for
the
the
decision
decision tree is
0.947
0.947
as
as
the
the accuracy.
and
And
then
then
you
you
can
can check
with
with
different
different
model.
model.
So you
So
can
you can
go
go
to
to the left panel.
So
So
in the
in the
model,
model,
you can
you
see
can see
there
there
are
are
many
many
kind of
of
model.
model.
Now
Now
I
I
think
think
I
I
cannot
cannot
explain
explain
everything.
everything.
So you can
You can
check.
check.
For
For
example,
example,
you learn
you
about
learn
the
about the
can.
can.
So you
So
can
you
use
can use
can
can
for
for
the
the classification.
You can
You can
use
use
SVM
SVM
for the
for the
classification.
classification.
You can
You can
use
use
stick
stick regression
for the
for the
classification.
classification.
Now,
Now,
my
my
question:
question:
Is it
is it
possible
possible
to
to
use
use
linear
linear
regression?
regression?
Error. Why?
Why?
So we
So
need
we
to
need to
understand
understand that
some model is for
regression
and some
and
model
some model is for
classification.
classification.
In
In
this
this
case,
case,
you
you
need to
to
check
check
the
the
error.
error.
What is
What is
this
this
error?
error?
It
It
mentioned
mentioned
numeric
numeric target
variable
variable
expected.
expected.
It
It
means
means
this
this
algorithm
algorithm
is
is
only
only
for
for
regression.
regression.
Now
Now
let's
let's
check
check
another
another
algorithm.
algorithm.
Nine
Nine
pairs.
pairs.
Okay,
Okay,
this
this
is
is
okay.
okay.
Now
Now
let's
let's
go
go
to
to
the
the
other
other
kind
kind
of
of
data
data
set.
set.
Now I'm
Using
using
the
advertising
advertising
data
data
set.
set.
Okay,
I'm
I'm using
using
the
the
advertising
advertising
data
data
set.
set.
Again, I
Again,
will
I will
use
use decision tree,
and
and
then
then
I
I
will
will
show
show
the
the tree viewer.
Now I
Now
will
I will
check
check
the
the
test
test score.
I'm
I'm
using
using
the
the
can.
can.
Okay,
Okay,
this
this
is
is
now
now
I'm
I'm
trying
trying
to
to
use
use
the
the
SVM.
SVM.
Okay,
Okay,
this is
this is
also
also
good
good
for
for
regression.
regression.
Let me
Let me
use
use
the
the
logistic
logistic
regression.
regression.
Oh, this
This
is
is
error.
L.
Why?
Why?
If you
If you
open
open
this
this
one
one
and you
and you
look at
look
this
at
one,
this one,
categorical
categorical
class
class
variable expected.
expected.
It
It
means
means
the
the logistic regression
is
is
for
for
classification.
classification.
Okay. So you
So
need
you
to
need to
know
know
that
that
some
some
algorithm
algorithm
can
can
use
use
only
only
regression.
regression.
Some
Some
algorithm
algorithm
can
can
use
use
only
only
classification.
classification.
But
But
some
some
algorithm
algorithm
like
like decision
decision
tree
and
and
SVM,
SVM,
they
they
are
are
also
also
good for
both
problems.
problems.
They are
They are
okay
okay
for
for
regression
regression
and
and
classification.
classification.
Okay.
Okay.
So
So
this
this
consider.
consider that one.
Now
Now
I'm
I'm
trying to
trying to
using
using
the
the
additional
additional
model,
model, for example,
the
the
random
random forest.
I'm
I'm
also
also
using the
using the
random
random
forest.
forest.
Okay. So if
So
you
if you
look
look
more
more
details,
details, actually
there are
there are
some
some
parameters
parameters inside this one.
There are
There
some
are some
parameters
parameters
here.
here.
There are
There are
also
also
parameters
parameters
here,
here,
and
and there are also
parameters
parameters here.
here. but because this is
This is
for
for the
introduction
introduction for you.
I'm
Just
explain
explain
the
the
algorithm.
algorithm.
If you
If
want
you
to know
want to
the
know the
details,
details,
you
you will learn more later after the mid exam.
for the mid
For the
exam,
mid exam,
just
just
use
use
the
the basic one,
and then
and then
try.
try to explain.
Now
Now
we can see
see
from
from
this
this
classification,
classification,
and
you can see that the best
algorithm
algorithm
from the
from the
accuracy,
accuracy,
the best
the
is
best is what?
F1.
F1. The
Best
best
is
is
the best
the best
is
this one.
best is
Best
this
is this one.
one. Logistic
Logistic
regression.
regression.
And
And
the
the
F1
F1,
best
the best
is
is this one.
for the
For the
precision.
precision,
The
the
best
best
is this
is
one.
this one.
For the
For the
recall,
recall,
the
the
best
best
is this
is
one.
this one.
Then
And
we
we
can
can see that
for
for
measurement
measurements, show that logistic regression
is the
is the
highest value.
highest value.
And
And
we
we
will
will
select
select
the
the
logistic.
logistic regression.
So you
So you
know
know
how
how
to
to
do the
prediction
prediction
methodological regression.
but
But
now
now, how do we know
how we
how
can
we can
explain.
explain the model?
So
So
here
here
we
we
will
will
explain
explain
the
the
model
model using
sharp.
sharp.
Sharp
Means the sharply at the tip
explanation.
explanation.
So this
So this
sharp is
is applied in explain module,
and
and
today
today I'm going to tell you about the feature importance and explain model.
So the
So the
input for
for
this
this explainable is two.
So the
So the
first
first
is
is
the
the
data,
data,
and
and
the
the
other
other
would
would
be
be
the
the
model.
model.
So the
So
data
the data
set
set
is
is
to
to complete the explanation,
and the
and the
model
model
which
which
is the
the
widget.
widget explains.
Now
Now
let's see.
let's see.
If you
If
have
you
the
have the
let me
let me
just
just because this is too
complex.
complex. Okay.
So
So let me check this.
the
The
best
best is logistic regression,
and
and I can just make it
another.
another.
Let's
Let's
say
say I'm
I'm
using
using
the
the
iris
iris
data set again, and
I will
I
use
will
the
use the
logistic
logistic regression.
Now
Now
I want
I want to check
again
again
one more
one
time.
more time.
Okay, so
Okay, so this is the best
among
among the other.
Now
I want to
explain
explain the model.
So
So the way to explain the model,
you need
you need to
this one.
this one.
Let's
Let's
say
say the first is I want to explain the feature importance.
So the
So
feature,
the feature importance,
I
I
will
will
from
from the input,
which
which is
data,
data,
and
and then I will drag from the
model,
model,
which is
is the logistic regression.
So
So
here
here
I
I
continue
continue
this one,
this one, and then
let's see.
let's see.
So
Based
based
on
on
this
graph,
graph,
what does
what does this mean? The
most
most important
from
from the AUC,
we can
we can see
the
the pectine
is
is
most
the most important features.
and
And then
next
next
is
is catalyst.
and then
And then next is
sepalid,
catalyst.
and
And the last one
is
is
catalyst.
sepalin.
So this,
So this shows
the
the
decrease
decrease in AUC.
So
So if we look at the pattern,
it
it
means
means
it is
it is
very
very
high.
high.
It
It
will
will
give
give
a
a
smaller
smaller value in AUC when you have even valve pattern.
You can
You can change
this
this score
based
based on the classification accuracy.
You can
You can change
change
score based on the F1. You
You can change the score based on the precision.
You can change
Based on the recall.
You can change
Based on the
MCC,
MCC and so on.
And
And if you look at this one,
most
of the parameters similar result.
So most of them
Show that
align
and pathology, there are two
attributes the most important
for
for
the classification.
So the
permutation means how many times you will repeat
this experiment.
experiment.
With five
Permutation,
the
the length and the petal width is the most important.
So it is the
It
same.
is the same
Reviewer. If you look at
this one,
with the
three
petal
length
is the
is
most
the most important features.
and then the
second important is petal width.
So this is
just precedence.
so
Those
both
model like the decision tree
and the
and
logic
the logic education,
they are
they are
fortunately give the same
explanation.
but sometimes
it is same.
So the
So the
output
output
will
will
be
be
the
the
selected
selected data instance that belong to the selected point in the plot,
or sometimes it is
about
the score. So the
So
score
the
means
score means
something that
you can explain
about the
the
importance
importance
of that attribute
attribute
or maybe
the importance of
that model.
that model.
So we use the
advertising
advertising data.
data.
Let's see.
If
I
I use this data set,
the
the
data
data
set
set shows the
best
one
is
is
random.
random forest.
Okay,
I will use the random forest.
So I
will use the data set
and
and then I will
do
do the random forest.
and then
Let's say again the present score.
So I will
connect this one with the data.
Okay,
So it is the same.
this is the
This is the highest.
and now
And now
I'm going to check
the
picture
picture explain.
Okay.
With the advertising data set,
we can see
we
use
the R square.
Use
Use the R square.
again.
The TV
is
the highest among the three attributes.
Radio
is the second highest.
Newspaper.
Okay, maybe this is not that important.
So what can we
explain from this one?
Spend more
on TV advertising
to
get
higher
sales.
Okay, so this
is how you need to explain.
The second
one,
the
the second
option
spend
also
on
radio
advertising
to
get higher sales. Because we have that are important. First is TV and radio.
The same
with this one.
We
can say
in order
to know
the flower in order
to know the flower, first
use
the petal.
So just figure out the petal, then you will easily know whether it is setosa or versicolor. If you still cannot know the flower name, then second feature use the petal width. Okay, so this is the two important features to understand the flower. So this is the interpretation. So select the performance method R square. The edge bit with high value show that the feature contributes to decrease the R square. So this is the important feature to decrease the R square. It means that TV is the most contribution to the sales. And let's say I'm using the RMSE. So we select one method RMSE, and the adjustment with high value show that the feature contributes to increase the RMSE. Increase the RMSE. It means if we increase the error, then the model is getting bad. It means TV is the most contribution to the sales. So we can see from those things, TV and radio. Now, we can also explain the model. When we explain the model, we will see something like this. Now let's see. I'm connecting this to explain the model. So in the explain model, it is the same. You need to connect from the data, which is the input, and you need to connect from the model. Then you can get model like this. Let me just start with the regression. Explain model and explain model. Okay. Now how can we interpret this? So for regression, sharp value is the sharp value for explanation. Shows how much the feature value affects the predicted value from the average prediction. So because this is the average prediction, and we want to check whether it affects positively or negatively. So color represents the value of its feature. So red color represents higher feature value, while blue color is lower value. So red color means high feature value, and blue color represents low feature value. So the color range is defined based on all values in the data set for a feature. So this data set, we can represent its of this dot with the data set. So a positive shape value means that the feature pushes the prediction higher. You can see here. So the TV, the high is more on the positive one. Because the high is more in positive one, so we can say it is the positive shape value. This positive shape value means the feature or this is the TV spending will give the prediction higher. So it will give a more or a better prediction. A negative shape value means it pushes the prediction lower. So when we have more on the low value, then it will push to the lower prediction. So if you see this one, most of the data are in the right. Then we can say this is more to be higher in the prediction compared to the low. So this is higher. This is also
Yes,
Yes, somehow we can say almost
balanced
balanced
between left and right,
and right,
but there are
there are
still
still
more
more
on
on
the
the
high feature
feature
value.
value.
What about
What about
newspaper?
newspaper?
So
So
newspaper
newspaper is not clear.
So we
So
can
we can interpret that newspaper might be
not
not
so contribute
contribute
to
to
the
the
sales. So
So this is about the
classification.
classification. Okay, so I mentioned to you before,
If we
if
use
you use
the
the
accuracy,
accuracy,
so
the
attribute
attribute
with
with
high
high
value
values
show
show
that
that
the
the
feature
feature
contributes
contributes
to
to
decrease
decrease
the
the
CE, the
the
classification
classification
accuracy.
accuracy.
Means the
Means the
petal
petal
width
width
is the
is the
most
most
contribution
contribution
to
to
the
the
flower.
flower size.
If we
If we
select the
select the
F1,
F1,
the
the
map attribute
attribute
with
with
high
high
value
value
show
show
that
that
the
the
feature
feature
contributes
contributes
to
to
increase
increase
the.
the F1.
So
So
the
the petal length in this case
is
is the most contribution to the flower type.
So
So
different
different
measurement
measurement
may
may
give
give
you
you
different
different
result
result
of
of the
the interpretation.
interpretation.
But
But
maybe
maybe
the
the
order
order is even.
the
The one is
petal
petal
width
width
and
and
petal
petal
length.
length.
This one
This
is
one is
petal
petal
length
length
and
and petal length.
and
And
for
for
this
this
iris
iris
data,
data,
it is
it
a
is a
little
little
bit
bit
different
different
because
because
we
we
have
have
three
three
classes.
classes.
In
In
order to
order to
see
see
the
the
model,
model,
it
it
means we
means we
want to
want to
see
see
this
this
on
on
every
every
class.
classes.
So
So
for the
for the
iris
iris
data,
setosa,
it will
it
be
will be
different
different
with
with
iris.
iris virginica.
It will
It
be
will be
different
different
with
with
iris
iris
versicolor.
versicolor.
So if
So
it
if
is
it
the
is the iris setosa, what is it?
as I
As I
mentioned to
mentioned to
you,
you,
the
the
red
red
color
color
means
means the
high
high
alpha.
alpha.
So the
So
red
the red
color,
color,
it
it
is
is
on
on over the negative side.
The other
The other
thing
thing
is
is
not
not that important
according
according
to
to
the
the
models.
models.
So
So
in the
in the iris setosa,
in
in
order
order
to
to
know
know
whether
whether
the
the
flower
flower
is
is
iris
iris setosa or not,
we can
we can
use
use the tantalizing
because
because
this on the
on the
model
model
it
it
shows
shows
the
the
feature
feature
value
value is high
and
and it
impact
impact
negatively
negatively means
you
you
can
can
know
know
that
that
this
this
is
is
the
the
flower
flower
setosa.
setosa.
Now
Now
let's
let's
see
see
with the
with the
other
other
flower.
flower.
If you
If
use
you
the
use the
versicolor,
versicolor,
if you
if
use
you
the
use the
versicolor,
versicolor,
now you
now
can
you
see
can
that
see that the petaling
show
show
more
more red
color
color
on the
on
right
the
side,
right side,
and the
and the
petal
petal
width
width
show
show
the
the
red
red
color
color more
on the
on the slips.
but
But
sepal
sepal
width
width and sapalang,
here
they are
not
not
so
so
effective
effective
on
on
the
the
model.
model.
So
So
what can
what
we
can we
say?
say on this?
Yeah,
Yeah,
again,
again, the length and the petal width contribute
to know
know
whether
whether
the
the
flower
flower is vertical
or not, because it
because it
is
is
more
more
in the
in the
positive.
positive way.
So we
So we
can
can
just
just
say
say that the petal length affects
most of
of
the
the
iris
color,
color, and the
and the
second
second
attribute
attribute
is
is the effect.
the
The
virginica.
virginica,
Then we
then
can
we can
see
see
this
this
one,
one, the petal width
and the
and the
petal
petal
length.
length,
Both
both
of them are
are
in
in
the
the
higher
high
value
value
in
in
the
the positive one.
then
Then
this
this
also
also represents that the petal width
and
and the
petal
petal
length
length
are
are
the
the
most
most
contributed
contributed
factors
factors
to indicate the
iris
virginica. The
The
sepal
sepal
width
width and sepal length
is
is
not
not
that
that
effective
effective
to
to
distinguish
distinguish
this
this
flower.
flower.
So
Higher gap value
or
or higher deviation from the center of the graph,
higher deviation
from the center of the graph,
means
means
that
that
the feature value has higher
higher
impact
on the prediction
for
for
the
the
selected
selected
class.
class.
So if
So
it
if
is
it is higher than this one,
so the gap here
here
in
and
this
this one is very high.
So
So
this
this
is
is
very
very
high
high
impact
impact
for
for
distinguishing.
distinguishing the isomers.
If
If you
see
see this one
and
and this one,
because
because
still
still there are many data here,
it
it is not that impactful.
So
So
positive
positive
step
step value points right from the center
are
of feature value that impact toward the prediction of the selected class.
The
The
negative
negative value points left to the center have an impact in
classification
indices.
You know what
What
the
do we
meaning
mean by against?
funding. So if you
Look at this one,
the
the iris person,
or
this one is
the
the
higher
higher
value
value on the negative value.
So
So
this
these
two
two
attributes,
attributes,
it
it
shows
should
impact
impact against
iris
iris
person.
person.
So if
If
you
you
know
know this one, then it will be easier to understand about fancy color and
vision. Okay, so
that's all about the explainability.
So you have two
two
things
things about the explainability.
interpret
The feature
and
and interpret the model.
So
So when you do that, yeah, you need to do two things. You need to explain the feature and you need to explain the model.
Okay,
Okay, let's have a break. I'll continue after the break.